Okay. So, getting equation in terms of x prime, y prime, we use sines and cosines, right? Right. So we're using theta equals pi over 4, right? Is that right? That we're doing? Pi over 4 to write 6x squared plus 6xy plus 9y squared equals 53 in the x prime, y prime plane. Right? And in order to do that, we had to get sine and cosine of this guy. Right? Yep. True enough. So, we use the formula x equals x prime cosine theta minus y prime sine theta. I can't write. For the x, and we used y equals x prime sine theta plus y prime sine theta. Oh yeah, that is what I meant to say. But in this problem, it doesn't matter because they're the same. Well, they're not quite the same, right? Because of the minus and the plus. Well, sine and cosine are the same, right? We remember where we are. We remember what we're doing. Kind of, sort of, kind of, right? Cosine of pi over 4 and sine of pi over 4 are the square root of 2 over 2, correct? Correct. So, x equals square root of 2 over 2 times x prime minus square root of 2 over 2 times y prime, which if we write as a single fraction would be x prime square root of 2 minus y prime square root of 2 over 2. And y is going to be the same thing but with a plus in the middle, right? Because 45 degrees, pi over 4. X prime square roots of 2 plus y prime square roots of 2 all over 2. Then we start shoving those into that guy, right?
Where did that over 2 come from? Oh, because you...
Just, yeah. It'll be the same steps as this one, just with a plus in the middle. So, it would be 6 times x prime square root of 2 minus y prime square root of 2 over 2 quantity squared plus 6 times x prime square root of 2 minus y prime square root of 2 over 2 times x prime square root of 2 plus y prime square root of 2 over 2 plus 9 times x prime square root of 2 plus y prime square root of 2 over 2 equals 53. Right?
So you're just
substituting.
putting it back in as x.
Yes. We want to turn the x's into x primes and the y's into y primes.
Okay, I understand. I don't understand how you can write that fast. That's okay. I have to think about this further. That's okay. You can keep going.
So, on the first term, we use the binomial square theorem. and square 2, which is 4. That's a 6, it's going to be. So x prime square root of 2 squared is x prime squared times 2, because square root of 2 squared is 2. And then plus 2 times these multiplied, so minus 2, because negative times a positive, times this, so times x prime y prime, and square root of 2 times square root of 2 is 2, so times 2. Let's make my minus more clearly a minus, so the dots and the minuses don't look like the same thing. And then the last one squared.
Wouldn't it be 4?
When I multiply 2 times 2, yes.
Oh, okay, yeah.
I was slowing down slightly since so many mistakes, well, I don't know that there very many mistakes were made, but to reduce the number of mistakes. This squared would be plus y prime squared. Square root of 2 squared is 2. This would be all over 4. Then the next one, we got conjugates on the top, right? So we just do first and last. So plus 6 times this times this is this, x prime squared times 2. And last would be negative y prime squared times 2. And 2 times 4 is, no, 2 times 2 is still 4. And the last one, we're just distributing the 9, but I'm going to leave it, well, no, that's fine. Go ahead and distribute the 9. Plus 9x prime.
It's supposed to be squared.
Oh yeah, that's why. It's like, why is that just that? Yeah, thank you. Yeah. Plus 9 times x prime squared times 2 plus 2 times x prime y prime times 2 plus y prime squared times 2 equals 53. This is all over 4. Right? Those are all over 4, so we can shove the numerators all together as long as we remember about the distributing here in a minute. All right? So, actually I say here in a minute, let's do it now if we're lucky. No, we shouldn't because I left those 2's unmultiplied. Okay, so 6 times x prime, no, let's put the 2 in the front.
So now you're just distributing.
I'm not distributing, I'm multiplying negative 2 times 2 and positive 2 times 2. I'm just cleaning up the insides. Going more slow than typical. 2 times x prime squared minus 4 plus, no, how about 4x prime y prime, right? Plus 2 times y prime squared plus 6 times, probably could go ahead and distribute that one, right? This and this. 6 times 2 is 12, so plus 12x prime squared minus 12 y prime squared plus 9 times 2x prime squared plus 4x prime y prime plus 2y prime squared. 53, and all of this is over 4. Now we can distribute the 6 and the 9. Six times 2 is 12, right? 12x prime squared minus 24x prime y prime plus 12y prime squared plus 12x prime squared minus 12y prime squared plus 18x prime squared plus 36x prime y prime plus 18y prime squared all over 4 equals 53.
So then we'll multiply both sides by 4, get rid of the fraction.
We can. That's totally fine. If we want to multiply both sides by 4 to get rid of the fraction, we get, what is 100 and something? No, 212. Yeah, sure. Multiply both sides times 4, and we get 212 over here. That's fine. We've also got some like terms up here. Let's see if we can find them. The x prime squareds are here and here and here. The x prime y primes are here and here. And the y prime squareds are here and here. Now we don't have a fraction anymore. We do have 12 plus 12 plus 18 is 42. Prime squared. And then negative 24 plus 36 is 12. And then 12 minus 12 is 0, plus 18 is 18.
Divide it all by 2.
We can divide it all by 2. So we have 21 x prime squared plus 6 x prime y prime plus 9 y prime squared equals 106. We bring the 106 to the other side to get everything equal to 0. We'd have all that minus 106.
Huh?
If we subtracted 106 from both sides, in order to get everything on one side, we'd have minus 106. And then all of that equals 0.
Oh, okay.
We need to identify the conic from this information and that information and all the things. Need to get some JB Weld or something and fix this. Facts. You have a scratch on your nose. Did a cat attack you?
No, I was doing makeup.
You were doing that's a much better story than a cat got me.
I was just being aggressive with the brush.
You were being aggressive with the brush.
Good. I'm glad you enjoyed it.
This one is copy.
Okay.
Or y'all copy back page with
The fog?
We need to figure out what kind of conic this is. So how can we do that?
Magic.
Yep. Mathemagic. So we have this. We can for sure, without having to do any mathemagic or anything else, we can for sure say it's not one of the conics. Which one?
Circle.
Okay, so yes, that's not even what I was talking about, but yeah, probably not a circle, because why?
Because the squares are not
Yeah, because what's multiplied times the squares are probably not the same, right? So it's almost certainly not a circle. Now, because of magic and math and whatever, maybe not, I don't know, we won't guarantee that. But that's not the one I was thinking of. A parabola. How can we definitely, like, without even, like,
A parabola only has one square.
yeah, because the parabola's only got one squared. It's the only one's got one squared. So it's definitely not a parabola. So we flip a coin, a three-sided coin, and we pick one and we write it. Yay! No, that's not what we do. That's not a good idea. So what we want to do is we want to check this.
Sometimes I wish you were see-through.
What does that look like / remind you of? Quadratic formula.
Oh yeah.
It's not astonishing that it should remind you of that, because yeah, it shouldn't remind you of that. So it should remind you of that. What is A, B, and C?
The prime square stuff.
21, 6, and 9.
21, 6, and 9.
What would it be? 21, 9, and 106.
Oh, what would it be?
Oh wait, yeah. It's horrible. Would it just be the first three because they have primes on them?
I think it's the squares and the not squared, because the x prime, y prime is two things multiplied together.
That is good logic and good reasoning. You just happen to be wrong. that was very great guess, very well guessed out. But no, it's not. That's not it. But that's like I love that you use logic to get there. We got A, B, and C.
So it's just not the one that doesn't have a prime on it? Always?
What?
So it's always just not the one that has the prime on it? Always?
All those have primes.
So not the one of things.
Well,
You mean the one that doesn't have a variable? Is
Yeah.
that the words you're looking for? Yeah. So B squared, 6 squared minus 4 times 21 times C, that's right, which is, in fact, 9.
Within 36 minus 756.
36 minus 756, which we could probably stop there, but we end up with negative 720. Now, what are we figuring? What are we looking at there?
is that how much it rotates?
Nope, but that's a good thought. We're trying to figure out what conic it is. That's our goal. What are we comparing that number to, do you think?
I'm thinking
That's a good thought, but no.
The vertex. Oh, don't give us anything.
We're comparing it to 0.
That is not 0.
That is not 0. That's true. Is it greater than, less than, or equal to 0?
Less.
It's less than 0. This is less than 0. Which tells us that this is an ellipse.
And if it were bigger than 0?
What do you think it would be? What's your guess?
Hyperbola.
Hyperbola. Because it's, yep, that's right. And if it was equal to 0, what do we think it would be?
Circle.
A circle. Look at that.
Kurt.
Look at that.
Mathematical.
Mathemagical. What?
Is that the one where you have to figure out what it is?
We were supposed to write, so there was two instructions. One, to write it in the x prime, y prime plane, which is this part. And then we had to figure out what conic it was.
With the thing on the left or on the right? Do we want the 0?
They put it on like with the other ones. But it kind of depends on what kind of conic it is, what you want, and all the things. So
So we're good.
it doesn't, I wouldn't care either way.
Yeah, your entire page for one problem. You're welcome now.
Why did they do that? They shouldn't have done that. They should have made it a different conic for the guided practice. That's fine. But that's fine. You'll get that part. That part you get. Well, actually, most of it you get. Just slow down enough that you don't make mistakes, honestly. It's really the trick, right? And remembering your sines and cosines of the exact term things. Yes?
Will we have the magical circle of numbers on our
No. No. That's one that should be in your head.
No, it's
And if it's not and it's oozed out, you got to put it back.
Magical circle of numbers?
Units. She means the unit circle. Yeah.
circle with all the numbers.
Oh, easy.
Yeah. Because like you just
Do the table.
you just go around and count. My brain
You're gonna have to
loses
tell me
it
the
out.
trick
Yeah.
because I don't know what you're touching.
0, 1, 2, 3, 4 is the trick. I taught you the trick.
No, we're talking about the circle.
That's the same thing.
0 or pi. 1 pi.
Okay.
The pi over 1 doesn't exist, does it?
So we got the A, the B, and the C, and all of those things. So
Let's do it again.
okay. So I'm trying to decide how much of this part to tell you, or if we just jump to this part. I'm kind of thinking we just jumped this part. But if we get confused, we go back to this part and hope that that doesn't confuse us more. That's what we're going to try.
We'll pray.
The last year, I didn't have a pre-calculus class. And yeah, sadness. And the year before that, I had a pre-calculus class of a bunch of kids that barely made it through Algebra 2 for the most part, other than one of them. And so we didn't get this far then. We got to trig and whatever else, I think. And then my first year teaching pre-calculus in homeschool class, not my first year ever, but my first year in homeschool classes, I had 2 kids in that class. One of the kids was really good at math and actually did his homework, and the other one pretty much never did any homework and was really bad at math, so we also didn't make it this far then. So this is the first time I've made it this far teaching this class, and so that's one of the reasons why in years. It's been a while since I've taught, it's been years since I've taught pre-calculus this far in public school, and so that's one of the reasons why we're a little bit halting and I have to sometimes make decisions and throw audibles. In case you're curious why it seems like I'm an idiot. It's partially because I'm an idiot and partially because it's been years since I've taught this far into pre-calculus. So, here we go. An angle of rotation theta a long one? It's a line and a half in the textbook. So
Well, Doing the
So,
math underneath it, and you want to see the thing.
yeah, if you want it to all match, that's true enough. An angle of rotation theta, or theta, if you happen to be the lady that teaches crash course physics, which I highly recommend as a video series. It's very good, actually. Angle of rotation theta such that cotangent to theta equals A minus C over B, where of course B is not equal to 0 because problems. Zero, an angle between 0, theta between 0 and pi over 2, yes? Is that what we're doing? Yes. Pi over 2 will eliminate the xy term, which is great because we don't want that because it's ugly and hard for us to graph. I feel like this sentence should have like an if statement, but that's fine. In the rotated x prime, y prime coordinate system. Let's look at what and why and all the things. How does that sound? Grand? Using a suitable is an example, by the way. That was not an example. That was a sentence. Using a suitable angle of rotation for the conic with equation (8x squared) plus 12xy plus 3y squared equals 4. Write the equation in standard form. Okay.
What should I label that up there, that definition?
You should label it eliminating the xy term if you want a label. Okay, so let's start by figuring out what kind of shape this is. How do we do that?
It's not a parabola.
True enough.
Then we can't use the formula because they're not round.
We can use the formula.
Oh, so we just use the formula.
Use that b squared minus
12 squared minus 4 times 8 times 3. 12 squared is 144. What is negative 4 times 8 times 3? 96. So it is going to be greater than 0. Therefore, hyperbola, right?
What in the world is the boxes for?
Is what's going to go in here.
Ah, okay.
It is a hyperbola. Yes?
Okay, so the rule again is less than 0 is ellipse.
Ellipse.
And then greater than 0 is
Hyperbola.
hyperbola.
And 0 would be a circle.
So it has to be less than, wait.
Okay. So we got to figure out what angle. So now what our goal is, it's a hyperbola. That's going to help us later to get it into standard form potentially. It might not help us at all. It might be totally useless. We probably could have waited till the end of the problem and figured out whether it was a hyperbola once we get the thing in standard form. But it will at least give us a direction we know we're going to. We're going to have something squared minus something else squared equals 1, right? All of those things. That's where our goal is. So at least kind of know where we're headed. Now, we need this to not be here. And so in order for this to not be here, we need to rotate it. We need to spin it, but we need to figure out how much to rotate it in order to get rid of that. Because we just did one, the one that we did at the beginning, it rotated, but it still had an XY term, right? So we need to figure out how much to rotate it. And we rotate it using that formula. What was the formula again?
Tangent 2 theta equals a.
Well, it's on the board, isn't it? Oh, look at that. I'm asking something useless. 2 theta equals A minus C over B. So, in this case, what is A? 8. Minus C, which is 3, over B, which is 12. 5/12, that's correct. So we need to figure out still what theta is, so let's draw us a little triangle. Cotangent is adjacent over opposite. That's true. So we put a 5 here, we put a 12 here.
Oh, and then we can just, what's it called?
Pythag? Yes.
We could Pythagorean theorem, that's true. We could even use some, we're gonna end up using something else. I don't know if y'all have seen all of that yet. But we do probably need to use Pythagorean theorem and get the fact that this is 13, right? Great, that's 13. So Pythagorean theorem, let me write that on the board. Get the full example. So 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. 25 plus 144 is 169 equals c squared. Square root of both sides, we end up with c equals 13. Bam, that's 13. Now, we don't want 2 theta. We want 1 theta. So, guess what you get to use?
Oh, it's been a minute, I forgot.
How about a double angle identity?
Oh, great.
Do you have to memorize it, or are we gonna have to chart again?
Actually, you don't even want a double angle identity. You want a half angle identity, right?
Will we have this available for the test, or do we have to memorize?
There's only one that you have to memorize, so you need to memorize it. Actually, there's two technically that you need to memorize. You need the sine and the cosine one, theoretically.
I'm gonna write down all the stuff.
Ancient yellow notes.
Your ancient yellow notes. What I think we're going to do to make our lives just slightly easier, your ancient yellow notes. That's funny. Took me a minute to realize what you were saying because Bree has like yellow flashcards, and so my brain went there. I think I'm going to let you bring a note card to the test that can be filled out front and back. Has to be your own handwriting. And it can have whatever the heck you want on it. Whatever formulas you want.
I think when we start the test, we'll just write things on it.
No, you bring it. Like you make you a note card that can be written on front and back, and that you can bring to the test. So you can put identities. You can put the standard forms of equations if you want. I don't care.
Okay, I found it, but which?
You can put the chart on there if you want. I don't care.
How big is the note card?
That's a great question because I would have yelled at you if you brought like a big old note card. No, a standard 3x5 note card, like that. Something that looks like that. It may not be typed, must be handwritten in your handwriting. You may not get your mommy to do it, or your sister.
I found the half angle identities, but which ones we use?
Good. Well, we kind of want them both. So sine and cosine.
Okay. Sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over.
Try again.
No, that's
Cosine 2 theta, right?
no.
Oh, because yeah, it does. You're right. Yeah, we're gonna rewrite it in a minute. Yes, you're right. Over 2. And the cosine of theta over 2 equals plus or minus, same thing but with a plus, right? Now, watch this magic. If we want to get to the sine of theta, we can turn that into a theta and put that as a 2, right? Because we have 2 theta right there. So now we're trying to find that because we need to get here.
It was sine over 2. You just took out the 2 and put it over there.
What I did was, instead of half theta over 2, I turned this into theta, which would mean these have to turn into 2 theta, right?
Okay.
So
Is that what we're going to use?
that's what we're going to use because our OG, our original, has a 2 theta in it,
Okay.
right? Okay, so we're going back over here. What is the cosine of 2 theta?
Adjacent upper hypotenuse.
True. So
5 over 13.
5 over 13. So the cosine of 2 theta in our problem equals 5 over 13. So, using half angle identities right there, we can find the sine and the cosine of 2 theta, right? The sine, not of 2 theta, of theta would equal plus or minus, although we really only want the positive one because we're not changing quadrants and doing all that nonsense, right? So the square root of 1 minus cosine of 2 theta, so 1 minus 5/13 over 2. And the cosine of theta would equal square root of 1 plus cosine of 2 theta. I wrote that wrong over here, didn't I? Plus 5/13 over 2. Cosine. That's correct. That is correct. That's why we had to do the triangle from the cotangent, because we're given the cotangent, but using Pythagorean theorem we can get the other side, and then it is correct that it's cosine. Okay, so this is 13/13. You could do this on the calculator if you wanted to, that'd be totally fine. So we've got the sine theta equals the square root of 8/13 over 2.
Negative.
No,
No, negative.
it would not be negative.
Is 13 and 13 is bigger than 5 13?
Right.
That's okay. So the square root of 8/26. Is that right? Cosine theta equals the square root of 18/13 over 2. So square root of, because reducing fractions, yes, 4/13. So this equals square root of 9/13. So this equals 2 over the square root of 13. This equals 3 over the square root of 13. So this equals 2 times the square root of 13 over 13. And this equals 3 times the square root of 13 over 13. I'm going to erase this theorem. What do we call it, a theorem? Probably. I don't know, this book probably doesn't, but I would say it probably is. I'm going to erase this part. So now we have the sine and cosine of theta, which is great, because now we can put it into the x prime, y prime axis. And if we've done everything correct, the x prime, y prime term is going to cancel. Before we move on, let's check and see if our part matches the book's part, and then we'll see from there. 2 times square root of 13 over 13, 3. Look, it does match. So we've got a fighting chance, unless they made a mistake, and then that would be depressing, because then we also made the same mistake. All right. Well, just give me a little dot so we can, it's the same problem, not a new problem, but we're doing new math. So in order to get this into the x prime, y prime axis using a rotation of, we didn't even figure out what that is, but using whatever that is, we could figure that out if we wanted to. Rotation of whatever theta we just figured out it needs to be. What formula do we use for that?
X prime cosine theta minus y prime sine theta.
Theta and
Equals
y equals.
x prime sine theta plus y prime cosine theta.
So x equals x prime times 3 times the square root of 13 over 13 minus y prime times 2, right? Yes. 2 times the square root of 13 over 13. So it equals 3x prime square root of 13 minus 2y prime square root of 13 over 13. Y equals x prime times 2 times the square root of 13 over 13 plus y prime times 3 times the square root of 13 over 13, which means that y equals 2x prime square roots of 13 plus 3y prime square roots of 13 over 13. How we doing?
I have it. I know what it means. I have it.
Well, we're not remotely done yet.
So you did.
I need to finish
So
them.
you just like
Yeah.
simplified all that.
Yeah. I just,
Yeah.
yeah.
And how do you know when you're done simplifying?
Can't do anything.
When you can't do anything else. Yeah. Okay. Now what do we do? Shove those into that.
Oh,
Oh yeah, this is Nike.
8 times 3x prime square root of 13 minus 2y prime square root of 13 over 13 quantity squared plus 12 times 3x prime square root of 13 minus 2y prime square root of 13 over 13 times.
Quantity squared?
No, because that's this one. That's this one. 2x prime square root of 13 plus 3y prime square root of 13 over 13 plus 3 times 2x prime square root of 13 plus 3y prime square root of 13 over 13 quantity squared. And then we keep going.
do the a squared plus b. Wherever it was.
Yeah, the binomial square theorem. Just, yes.
What's it again?
A squared plus 2ab plus b squared. All right. 8 times 3 squared is 9 times 13. What's 9 times 13?
117.
117 x prime squared minus 2 times 3 times 2 is 12, right?
Move on. We are just.
I am squaring this binomial.
Got it. So we're not distributing it.
No, I am distributing. Not distributing the 8. Is
Yeah.
that, yeah. 12. Oh, we said it was 12 times 13, right? What's 12 times 13? 156. Yeah. X prime, y prime, which if we're real lucky in a minute, that's going to disappear, but keep on. Plus 4 times 13 is 40 plus
Like however gets to the 117 again.
3 squared times 13. So 9 times 13.
Well, it's so nice that all the square roots are going away.
4 times 13 is what?
52.
52 y prime squared plus 12 times first and last. It's all going to be over 13 squared, right?
Wait.
3 times 2 is 6 times 13. What is 6 times 13?
78.
78 x prime squared. Excuse me. Last is minus 78 y prime squared plus 3 times, all this equals 4, I suppose.
I suppose.
2 squared is 4. We did that already, right? 4, that's the 156. Six x squared x prime squared. And then the middle is going to be the same thing, but plus, oh no, that's 107, no, wait, no. That's 52 x prime squared. The middle is going to be the same, but plus 156 x prime y prime. And this one will be the 117 plus 117 y prime squared. All of this is over 13 squared. What is 13 squared?
169.
Oh yeah, I did know that somewhere in my brain. 69. And this still equals 4.
56.
Then we distribute. Yay. Got a parentheses somewhere right here.
I'm like back at these notes and not understand anything because I don't have enough space to write it all down.
Well,
Don't write
you
this
may need to go back to the video and recopy some of these parts or whatever if that does happen. All right, 8 times 117 is what? 936 x prime squared. These are definitely going to cancel because it's the same but opposite. So we could just skip it, but I'm afraid that might be confused. The multiplying 8 times, oh, it's not going to be the same, but what? Don't tell me we did something wrong. Because it's the same, but 8 and 3 are not the same. Time is it? It's time to leave. I can give you all a couple homework problems to get us toasty. Yeah, give you a couple homework problems and we'll let Alexis check our math at home and then we'll figure it out later. Except she probably won't have time because I'm actually going to give some homework. So who knows? Homework page. It's almost certainly in, oh no, it shouldn't be. It might be in this part. Homework is on page 459. And we're going to do 2 through, is it like 8 or something? 10. 2 through 10. evens.
Is it page 459 or 452?
459. Oh. I said 9 both times, but wrote 2 for some reason. All right. That's it. That's all we're going to get done today.
Okay.
Where did those numbers even come from? On the outside?
Which ones?
8, the 12, and the 30. Where did that? Okay. Oh, yeah, because it's the.
I've already, like, I have 4, this is, I'm working on my 4th pages of notes for this lesson.
Yeah, it's in here that or something. No, I'm looking at a different problem now. Did I turn the page? Yeah, I did. Oh, I did turn the page because I needed to look at homework.
Can I take a photo where it's doing this in the book so I can try and figure out what we messed up?
You don't have. It should be in your book too, right? Page 456.
Oh, wait.
Like the answer.
Well, this is the example, so I mean, it's not any different than what's in your book, but yeah,
I can never remember which one I'm on.
yeah. Because I did the example instead of the guided practice. Okay, see you later.
And we're going to have a test on
You're going to have a test, so we will finish this lesson next class. That we